Question 1. Question 1 is an expand and simplify question. Remember, when we are doing our homework, we want to write everything out, please, as it is on the Weebly website. So, expand and simplify. And we're starting off, you may have noticed that these homeworks, they start off in week 1 quite a bit easier than they end up with in week 6 or 5 or 6 and that sort of thing. So, now there's a bunch of different methods for this, but I would probably use the FOIL method. You could use a grid method as well. That would also be absolutely fine. I would tend to use the FOIL method. So the FOIL method is first times by first, which is x times by x here, which is x squared. Then outer, so x times by plus 6. I'm going to consider all of that. That's important. So that's plus 6x. Inner, which is plus another 3x, and last, which is 3 times 6, which is plus 18. And now all I need to do is simplify that, which means just collecting these as like terms. So that's going to be x squared plus 9x plus 18. I'm going to underline my answer. I'm going to put a line in before question 2, and I'm on to question 2. Question 2 is factorization. Factorize. It's a simple factorization in this case. 16x plus 6. By simple I mean we've just got one term, one thing to remove as a common factor. So the highest common factor of 16x and 6. Well, I haven't got any variable here, so I'm only looking at the coefficients. It's important we get this language right. So the highest common factor of 16 and 6 is just 2. So 2 is going to go outside the brackets, and inside the brackets, what do I have to times 2 by to get 16x? 8x. What do I have to times 2 by to get plus 6? Plus 3. There's my answer. Any working out you wanted to do there, you could do, like highest common factor. That one was easy enough that I could go straight to it, really. I'm on to question 3. Right, question 3 is a new skill. So it is useful that I've got this recording, and it is hopefully, and over time, when we come onto this part of this topic area, and some of you guys may have already covered it in one way or another, we're going to be factorizing quadratics. Okay, so we're going to factorize, in this case, x squared plus 3x plus 2. Okay. Now, when you're factorizing a quadratic, what you wanted to do is it's the opposite of the expanding brackets like this. This generates a quadratic, and this is the factorized form in 2 brackets. So I need to put it back into that kind of form. So what I'm going to do is firstly just write out my brackets like this. So I would tend to do it like this. So then I'm thinking, these are all positives. So that means I've got no negatives here at all. So these are both going to be positive. It's going to be something plus, an amount of x plus something and something else here. Now the only way I'm going to generate this x squared is if I have an x times by another x. So I can fill that part in. Because that's going to produce, when I do a FOIL, the first, that's going to produce that x squared. Now, this last bit here, 2. If that's a prime number, it's going to help you a lot. Okay, because I know the only numbers that can go in here are 2 and 1. Okay, because this is how I'm going to multiply them together to get 2. Okay, so these are the factors of 2. So, in the beginning, when you do these questions, it's always going to be a prime number here. It's more difficult when this number is not prime because you have more factors to contend with. Now, in this case, they can be either way round, right? X plus 2, x plus 1 is still going to give me the correct answer as x plus 1, x plus 2. So that is correct. But these could be either way round in this case. If there's a subtraction in there, they can't necessarily be either way round. But when they're both additions, this is going to give me, when I FOIL this out, it would give me x squared plus 1x plus another 2x, which is, when I collect it, would be plus 3x, and then plus 2. So this is the reverse process of expanding brackets. And that's question 3. We'll move on to question 4. Okay, question 4. I'm going to do a bit of changing the subject of a formula. Make x the subject. I've drawn a strange U there. The subject of y equals mx plus c. So that's your general formula for, for working out the y coordinate. If you've got the gradient, the x, an x coordinate, and the intercept. Okay, but let's say instead of that, I wanted to work out the x coordinate. So the whole point of changing the subject of a formula is to be able to work out a different variable. So this gives me the y coordinate if I have all those 3 other things: the gradient, an x coordinate, and the intercept. But if I had, let's say, the y coordinate and the gradient and the intercept, I could work out the x, but only by changing the subject. So when you're changing the subject, let's be right, y equals mx plus c. Set it out really carefully for yourself, guys. So we're going to set it out like this, and then I'm going to keep it nice and evenly balanced. So I need to get x on its own. I need to make x the subject. First thing I'm going to do here is going to take away c. But if I take away c there, I'm going to take away c here using the inverse operation. So I've got y minus c over here, and I've got mx over here. So I've got mx means m times by x. So I've just got one more step here, and that's to divide by m. If I divide this side by m, I have to divide this side by m. And it's the whole of this side that I have to divide by m. So y minus c, all of y minus c over m is x. There's my answer. And we're going to put a line in, go on to question 5. Question 5. Work out 28 divided by 0.5. Okay, 28 divided by 0.5. Okay, so with this one, if I'm dividing by 0.5, hopefully you guys know now, dividing by 0.5 is the same thing, dividing by half, same thing as timesing by 2. So it's basically how many halves are in 28. So if you think about it that way, well, there's 2 halves in 1, so it's just going to be 28 times 2. But I'll show you a couple of different methods you could do for this. So firstly, I could use an equivalent fraction method. So 28 divided by 0.5 is the same as 280 divided by 5. That's just using equivalent fractions. So you could do that. Then you could do a quick bus stop if you want. I'm just showing you a few different ways you could tackle this. So 280 divided by 5. 5 goes into 2, not at all. 5 goes into 28 5 times. 3 is left over. 5 goes into 36 times your answer is 56. So you could do that. Or you could say, right, 28 divided by 0.5 is 28 divided by a half, which is the same as 28 times by 2 over 1, which is just 28 times 2, which is 56. So there's that method as well. So there's 2 methods you could use. Just dividing by half, same as timesing by 2. Dividing by third, same as timesing by 3. Right, question 6. Hey, Asha. Question 6. Question 6. Question 6 is this one is pretty straightforward for a higher A. So question 6 is just work out 2/5 times by 1/4. Now the only thing that I think people tend to do with this one is they try overcomplicate it for themselves and try to make the lowest common multiple denominator and stuff. That's only needed when we're adding and subtracting. When we're multiplying fractions, we're just going to times the top by the numerator by the numerator, the denominator by the denominator. That's going to give me 2 out of 20, which I can simplify to 1/10. Question 7. Right, this one again is a straightforward one. Divide 42 in the ratio 2 to 5. So if you just got a simple dividing in a ratio, this is one of those where you can add up to find out how many parts you've got. There's 7 parts in the whole thing, and so 42 is 7 parts, because the whole thing is 7 parts. So 1 part, because the question you need to be asking yourself is how much is 1 part worth. 1 part is 42 over 7, which is 6. So 1 part is 6, so I've got 2 times 6 on one side, which is 12, and I've got 5 times 6 on the other part, which is 30, and there it is, 12 to 30. Right, question 8. Right. Y equals 6x minus 1. Find y when x equals half. Little simple substitution one. Again, this will get more difficult over the weeks. Just always take your time to be careful when you're substituting, that you're going to substitute in brackets, just wherever you see whatever the symbol is that you're substituting in. You're just going to put it in brackets. You're not going to do anything until that is done. Then you can do the working out. In this case, it's really straightforward. So 6 lots of a half is just 3. Take away 1, so y is 2. Next question, question 9. All right, okay, this is one which you guys tend to struggle with a bit. It's averages problem solving, and I think in one of your past papers you guys really did find this kind of question difficult. So the mean of 5 numbers is 5, and the median is 6. List the numbers. Now, I think there would be multiple answers for this, but there are some things that have to be. There are some ways that some things that has to be, but there are multiple answers for this. So, the first thing I'd do, I guess, is think about these 5 numbers. Kind of have blanks for them. And think if I can fill any of these in straight away. And I can fill in the median, right? If these are in order, this one's going to be my median. So that one's going to be 6 there. So the next part, the mean of 5 numbers is 5. So I've got that 6 in place to start with. And then I need to think, right, mean of 5 numbers is 5. So it's the total divided by 5, how many numbers I've got, because I've got, and that's going to give me 5. So if I times both sides by 5, then my total is 25. So how much have I got left to share? If I do 25, take away the 6 which I've got already, I've got 19 left to share out amongst the other 4 numbers, which is why I can have perhaps lots of different answers. But you know, just to make it easy, so I'm just going to put some in. I'm just going to put some in, see where we go. If I made this one 1 and 2, this needn't necessarily be your final answer. You can play around with this a little bit. If I made that one 1 and 2, I've still got, so that's, now how much more have I got left to work with? Well, I've got 19 take away 3, which is 16. I've still got 16 left to use up. And I can use them up however I like here, as long as any one of them is bigger than, is 6 or higher. So I could just do 2 8s. Or I could do a 7 and a 9. Or I could do a 6 and a 10. Or, and that would be it. That would be all the different ways I could do it. if these ones are 1 and 2. There would actually be an infinite number of solutions, because if I did minus something here, or 0 and something, you know, then I could actually have an infinite number of solutions to this problem. That's question 9. Now I've run out of space, so I'm going to just, you guys may have some more space, but I wanted you guys to still be able to see that previous one, so I'll do 10 on this piece of paper here. So question 10 says, it's a solving equation, so solve 2x plus 3 over 2 equals 4. So I've got to undo this situation. So I've got 2x plus 4, and all of that is divided by 2. So to undo the situation and get back to x, I need to times both sides by 2. Times that side by 2, times this side by 2. That gives me 2x plus 3 still on this side, and gives me 8 on this side. Now I still need to get at that x. And at the moment this is 2 times by x, take plus 3. To get at the x, I shouldn't divide by 2 yet. You know, because I'd also have to divide the 3 by 2. So it's a better idea for me to take away 3 from both sides first. So it gives me 2x equals 5. Now don't worry that you're going to end up with a fraction. That's absolutely fine. I'm going to divide this by 2. Divide by 2. So x is, and I'm just going to write this as a fraction, 5 over 2. Now, if it's not asking you to have it in a specific form, 5 over 2 will be absolutely fine. But if it wants it in a specific form, let's convert from an improper fraction to a mixed number. 5 halves is 2 wholes and 1 half. And there's my answer to question 10.